Hi again. In this video, we're going to talk about the job sequencing through two work centers. In this case, what we could use the Johnson's rule, which is a technique that managers can use to minimize the make span. So again, the make span, basically, this is the lead time. Think about it as a lead time. How long will it take you to finish one job? But the only difference is not only one job, we have a multiple jobs. So how long will it take you to finish all these jobs based on the lead time for a group of jobs to be processed on two machines. So now we have two machines that we need to use them or at two work centers, sometimes referred as a two machines flow shop. So let's take a look into what the Johnson rule and how we could apply it. So the application of Johnson rules begin with the listing of all jobs to be scheduled and how much time will be required for each job at each workstation. So we look into each job and each workstation, and then we will do we'll determine the sequence, and the sequence will come through this. Select the job with the shortest time. So this is the first time you look into the shortest time and select that job. If the shortest time is at the first work center, schedule that job first. If the time is at the second work center, you want to schedule it last. Break ties, sometimes you will have a job, it doesn't matter if you have both work centers has the same time, so you don't want to do the it doesn't matter where you put it, on the front or in the back. Eliminate the job and it's time from further consideration. Repeat step 1 and 2, working toward the center of the sequence until all jobs have been scheduled. Successful application of these steps identifies the sequence with the minimum make span, or all work is completed as soon as possible. All right, so this is the theory behind the Johnson's rule. Now let's take a look into an example and how we could apply it. So we have a group of 6 jobs to be processed through two machines flow shop. The first operation involves cleaning and the second involves painting. Determine a sequence that will minimize the total completion time for this job of this group of jobs. Processing time are as follows. So we have job A, B, C, D, E, and F, and we have work center 1 with the timing and the hours, and work center 2 in hours. So the first thing that we need to do is to list a blank of sequence, first, second, third, fourth, and fifth, and sixth, and then we'll go to the table and select the shortest processing time. And you will find, if you go back to that table, you will find D will have the shortest processing time of 2 hours. So therefore D will go first, and then D is eliminated. Now moving into the next job, the shortest one would be B. However, B is in the second work center. So what we need to do, we need to schedule B on the end. So the B is the next one because it's in the it's the second shortest. So, but it's on the work center 2. So we will put it toward the end. Now moving into the next one, the next shortest would be A, but as you see, A has both in 5. So that means it doesn't matter where you put it, on the second place or the 5th place. So let's assume that we're going to put it on the 5th place as they did the textbook here. Now then the next one would be E. As you see, there is a 6 right there. That's the shortest processing time. So that E will take the second, and then moving into there, we will move to the next one between the 3rd and 4th. That would leave you with 2 jobs. So if you look into what would be the next here, would be the C. If you look into the C, that would be processing time 8, which is shorter than F of 12. So now the sequence would be D, E, C, F, A, and then B. So that's the sequence. And now what we need to do, we need to build a Gantt chart or something to look at what would be the idle time. So if you see in a work center 1, we will have D, E, C, F, A, and B. We need to consider the time for each one of them. So for D will take us 2 days, and then E will start on day 2, and we'll finish on day 8. And because there are 6 days of processing time and so on. And for center 2, we can't do anything on the first 2 days because we have to wait until we finish. So we will receive D on day 2, which will take us 7 days to finish. So that would leave us with we would finish D on day 9. And so on. So now look into the idle time. You will see there are 2 days at the beginning right there. And there's also another 2 days right there. So we have an idle time of 2 for center 2. And we have also an idle time between 37 and 51. That's also idle time. We don't use that center for that much of time. This is how you could make some decisions. So what I want to do, actually, I want to share with you my Excel screen here. Excel is a very powerful technique and software that I love using it all the time. So let me share with you what we did here. We have this question given to you, A, B, all the way to F, and we have the times for each process for each center. And now let's, once we look into the shortest, we found the shortest between all of these would be D. So I listed D here to be the first, and then moving to the next one would be B. So D would be 4, and again, or 3, because this is the 3, it's on the work center 2, so we schedule it at the end, and then the next one would be A, and doesn't matter because both has a 5 and 5, so we did agree to put it on the end by B. And then moving into the shortest, the next shortest would be E. As you see, that would be with a 6, so we put it on the left side. And then and we do the same thing again and again until we have the sequence D, E, F, A, and B. And this hopefully will help you. I did use the numbering here to help identify which one would be the shortest, and based on whether it's in work center 1 or work center 2, we could place it on the right or on the left. Now, once we agreed on the sequence on the schedule, so we could rank them this way: D, E, C, F, A, and B. And now let's do the calculation. So on job D, we'll start with the day 0. That will take us 2 days. As you know, here is the processing time for work center 2, so work center 1. So that would be 2. And then the next would be E. And then we will receive E on day 2. That will take us 6 days. That would be 8. And now moving into C, we'll start C with on day 8, and then we will finish it on 8 plus 8, that would be 16. And then we will start with F on day 16, and that will take us 12 days to finish. So 12 plus 16, that's 128. And then moving into this one here, 28 to 33, that will take us, because 5 days to finish A, and 33 starting date for B. And that will take us another 4 days to finish it. So that would be 37. So we're done with part, the work center 1. And now let's go to the work center 2. Work center 2 will receive the job D on day 2, and will be done after 7 days. So 2 plus 7, that would be 9. And moving into E, E would be, we'll start with E on day 9, add to that 8. Then 17, that would be the start date for C. Add to that the processing time for C, which is 9, so that would be 26. However, here we have to stop right here. We can't start 26 because we have to wait for this to finish, work center 1 to finish. So we have to start on day 28. Therefore, there is the 2 days idle. In now moving from there, 43, 43 coming from 28 plus the 15, the processing time, and then and so on. We do the same thing. As you see, we have only 4 days as an idle time. That would be 1 at the beginning and 1 on job F. And now also for the idle time for work center 1 would be the difference between 37 and 51, which is that would be 14 days as the idle time for work center 1. And that would be the Johnson rules for scheduling jobs when we have 2 machines or 2 work centers. I hope this is helpful. Please let me know if you have any questions. Now we're moving into the bottleneck operations and how we could manage the bottleneck operations. Thank you.